Hello and welcome to section 1.3a, graphs of functions, and in this section we're going to talk about the vertical line test and increasing versus decreasing of functions. So the vertical line test, if we've talked about it before, is basically where if you have a graph and a vertical line crosses 2 points on that graph, then that is not a function. So for example, if you're looking at this graph over here, this graph right here, you will notice that the vertical line crosses 2 y values. So for this x value, there are 2 y values. So this graph is not one-to-one, so therefore not a function. Because for one x, there are 2 different y values. Down here, this one is a function, because as you can see with the vertical line test, that the graph itself, the vertical line only crosses the graph at one value. So for every x, there is only one y value. So then they're asking me to use the vertical line test on the graph of this. So let me get out my calculator here, and I'm going to graph -1 divided by 4x, x squared. So then when I graph it, it looks something like this. So I'll just pull this over here, and you may notice that this is an upside down parabola of 1/4. So if I was to draw vertical lines in this function, anywhere in this function, doesn't really matter where, you could see that this graph has to be a function, because for every x value that I chose, and any ones that I didn't choose in this case, for every x value that I chose or didn't choose, there's only one y value. So that means that this is a function. And so that's how I would use the vertical line test to determine whether this is a function or not. The other thing that we're going to talk about is how a function is increasing or decreasing. And basically here is what the book says about increasing and decreasing. And you can see that if your x, it's increasing if your x1 is less than x2. So I'm basically picking a number to the left. And if it's smaller than the y values, then this graph will be increasing. And likewise, you can kind of read through these, but let's do this in a little bit more of a practical way of looking at this. And so what you can see is that if I pick a value here, if you notice this graph, and you always read graphs from left to right, just like you're reading a sentence. So as my x values are moving from left to right, you can see in this case up to this point right here, we're increasing. The graph is going up. So as I'm increasing my x values, as my x values increase, you'll notice that my y values are increasing. So as x increases, so between -infinity to, it looks like, about -2, as my x values increase, my y values increase. So this is what we call an increasing function. You'll notice that as my x values are increasing, as they keep going across the page here, you can see from -2 down to, it looks like, 0 down here, my graph is falling. And so then from -2 to 0, my graph is decreasing. And then as my x values continue to increase, as they get bigger, you'll notice that after 0, my graph goes up and off the page. So that means that from 0 to +infinity, I am increasing. So looking back at what this says up here, you're increasing if your x value, whatever x value you plug into your function, gets you a y value that is smaller than the x value. As the x increases, the y's increase. Over here, as the x's increase, the y's decrease. And if the x's increase but the y's do not, then you have a constant function. Then they're the same, they're constant. So that's really what we're talking about, and that's what all of this is saying up here, is as our x's increases, as we move across from positive, we end up getting bigger. And so that's increasing and decreasing. So if you have any questions about this, please come to class prepared to ask them.